we are going to take a look at something here today. It's drop dead simple, but very complicated and very involved. It's going to take a lot of writing. There's no other way to get around this. So, here we go. We're going to talk about solving systems of equations. Now, we have done this already with two variables. That's not a problem. Now we're going to move it up to 3. And that isn't any different. It just takes more time to go through and do it. Now, whenever we give an answer for these things, we need to put it into what's called an ordered triple. We did it with an ordered pair, for graphing, x and y. Now we're going to add z with it for x, y, and z, so there'd actually be 3 dimensions that we'd be looking at. Now, this is in your book. I don't want you to write it down now. You can go and write it down after a while. But these are the steps that you've got to go through. Okay? We're going to use elimination to get rid of one of the variables in one equation. Get rid of the same variable in another. Get 2 resulting ones. We just keep working it down. I don't want to spend that much time going over them. I want to spend more time working on these things and seeing how they go. Now, there are solutions just like we had before. If they hit once, you got consistent and independent. Infinitely many, consistent and dependent. We've seen these before. This is nothing new. None is inconsistent. So, what I want to do is I want to take my time real slow and do these problems. Now, I would recommend that you write these down as I am going so that you can get the steps. Granted, this will be, you can watch it at your leisure, when you have nothing else better to do and you need something fun to do, you can always watch these online, right? Okay, so the object here is going to be to get rid of one of these variables, either x or y or z. Now, when I look at this, I see that I have z, and I have z, and I have z. I am going to get rid of these first. I'm just going to go and ditch the z's because they're all by themselves. Nothing to do. So what I am going to do is I am going to use the first, second, and third. So I'm going to take 1 and 2, and then I'm going to take 1 and 3. So I'm going to write down this first as x plus y plus z is equal to 4, and 9x plus 3y plus z is equal to 0. That's one pair. Then I am going to take 1 and 3. Now, honestly, it doesn't matter which ones you take. I'm just using 1 because it's fairly simple. So I got x plus y plus z is equal to 4, and I've got 4x plus 2y plus z is equal to 1. This is my starting point. Now, the whole idea of this is to have 2 equations with 2 unknowns. We know how to go through and solve those. So, here we go. If I want to get rid of this z here, I can multiply one of these equations through by a negative. Remember how we were doing this before? So I'm going to take this top equation, multiply through by a -1. So that gives me a minus x, minus y, minus z is equal to -4. And when I combine these together, I end up with 8x plus 2y. My z's are now gone, right? Equal to -4. I am going to do the same thing over here. I want to get rid of the z's. I get rid of the z's here, I get rid of the z's over here. So I'm going to multiply through by a -1 as well, because that's what we'll get rid of. So negative x minus y minus z is equal to -4. And when I combine these two together, I end up with 3x plus 1y. That drops out is equal to -3. Now we have a pair of equations just like we were doing earlier. If I look at these, I ask myself the question, okay, which variable should I get rid of? Do I want to get rid of the x's or the y's? Well, I've got an 8x, and I've got a 2, and I got a 3y. I've got a 2y over here, and I've got a 1y over here. So to me, it would be easier to get rid of the y's. I would have to multiply through by a -2. So we take this, multiply that equation through by a -2. So -2 times 3 gives me minus 6x. -3 times this gives me minus 2y. -2 times this gives me 6. You combine these together. 8x minus 6x gives me 2x. 2y, -2y, disappears. And here I end up with 2. So now, last thing I do, divide by 2, and x is equal to 1. Okay. I had to go through all of those hoops to get to. Now what we're going to do is work our way back up to find out what y and z are. Now, just like before, we can take the variable or a value for the variable that we got, plug it into any equation we want because we've got nothing but equality going on here. Same thing here. So what I plan on doing is I am going to take this and plug it in to this equation up in here. I could have chosen this one over here, but this one was easier to work with. So I get 3 times 1 plus y, because 1y is just y, right, is equal to -3. So that means I've got 3 plus y equal to -3. Subtract 3, subtract 3. Y is now equal to -6. So now I have got x. Now I have got y. Now the last one I need to find is z. Now, I can pick any of these 3 equations. Now again, we said that x was equal to 1, correct? Y was equal to -6, yes? So I can take these and plug it into any one of these 3 equations. Which would make the most sense to plug it into? 1, 2, or 3? 1. Easiest one to work with. So that means that it is going to be 1 plus -6 plus z is equal to 4. Combine these together, I end up with -5 plus z is equal to 4. Add 5, add 5, and I get z is equal to 9. So, what this means for the final answer. If I did everything right, the final answer would end up looking like this. 1, comma, -6, comma, 9. Boom. And I've got it all right there. Like I said, this is a lot of writing. There is no other way that you are going to get through this. So, does anybody have a question in their mind right now about what I've done? It seems so that you can kind of, you got a question about something that you say bothers you. let's take a look at another one. So, now this one is going to have infinitely many solutions. I don't know what it's going to look like, but I'm still going to go through the entire process. Now, I am going to look at this and I'm going to say which one of these would be the easiest things to get rid of. Would it be the x's, the y's, or the z's? Well, I look at this and I think my best bet would probably be the z's, because I've got these two right away that are going to be wiped out pretty quickly, right? So, here we go. I am going to take that middle equation, and that is going to be, and the third equation. So I'll do negative 6x minus 12y minus 8z is equal to negative 56. And I will take 4x plus 6y plus 8z is equal to 24. And when I combine these together, add here, so we get negative 2x, add over here, negative 6y. This disappears, and these two equal what? Let's see, that would end up being 32. Negative 32. Okay, so I've got that set of equations. These are gone. Now I said I was going to I will pick on the first and the second. So I will take 2x plus 3y plus 4z is equal to 12. Then I am going to take my negative 6x minus 12y minus 8z, and this is going to be equal to negative 56. Okay? I got to get rid of the z's. So, multiply this equation through by a 2. Yes? So 2 times 2 gives me 4x over here plus 6y over here. That's going to give me plus 8z equal to 24. So far so good. Math looking good. So now I can combine these together. I end up with negative 2x minus 6y, that disappears, is equal to, and that turns out to be negative 32. Correct? Now, I'm noticing a bit of a problem here. This equation and that equation are exactly the same. If I try to get rid of an x, or if I try and get rid of a y, everything's just going to disappear, right? So just to do that mathematically, I'm going to take this one here, multiply it through by a negative 1. So negative 1 times negative 2 is 2x. Negative 1 times negative 6y is 6y. Negative 1 times 32 is equal to 32. So when I combine these together, that disappears, I get 0 over here. That disappears to 0. 0 is equal to 0. So what this is telling us is just like before, when we get 0 equals 0, or a number equal to number, where the equality is true, this is infinitely many solutions. This means that it will have, that each one of these will create or have the same lines, multiples of each other. So that's what that looks like. So if I get down to this point, 0 is equal to 0, infinitely many solutions. So that kind of goes back to this deal that we had here, infinitely many, consistent or dependent. Means the same plane or planes intersect in a line. That's all it means. So that was 1. That's 2. So far so good? try 3. Now this is not going to have any solution, so we are going to use the exact same ideas as before. Now I look at this one, which one should we get rid of? Should we get rid of the x's, the y's, or the z's? X's, that looks a lot better. So if I go and take the first one up here that has x plus 2y minus 3z is equal to 4, and I take the second one here, minus x plus 5y plus 3z is equal to 1. Okay? So x's disappears. I get 7y, z's disappear, and I end up with 5. So, does that seem right? But is 5 over 7 a legal number? Okay, that was kind of weird. Well, let's take care of, how about if I use the second and the last one? If I go and take 2x plus 4y minus 6z is equal to 3, and negative x plus 5y plus 3z is equal to 1, right? So if I go through and do this one, I got to get a common, one of these to wipe out. So I'm going to take this one here and multiply it through by a 2. Would that be okay? Would that work? Yes, no, maybe so. Possibly. So, negative 2x, this goes to plus 10y, this goes to plus 6c is equal to 2. So when I combine those two equations together now, and sometimes when you're writing this out, you might want to make sure that you're writing it in a nicer format, but we know that this is gone completely. So 2x and negative 2x disappear. 4y and 10y give me 14y. Negative 6c and 6c disappear. This turns out to be 3 plus 2, which is 5. Okay. Divide by 14, divide by 14, so y is equal to 5 over 14. Did we do all the math right? I don't see any place where we messed up on the algebra, did we? Okay, so if you're writing it all out, if you have showed all your work, and if you get something like this, is it possible to have a solution? And the answer is no. There is no solution. Where did I mess up? Yes, but I solved 2 different sets of equations, right? I solved this equation here and this equation here. I solved that pair. And I wanted to get rid of the x's, okay? But when I got rid of the x's, I also got rid of the z's, didn't I? It just happened that way. When I was over here, I wanted to get rid of the x's again because I did that here. But when I got rid of the x's between these two, and I ditched the x's, I also ditched the z's, right? They disappeared on me. So, no solution. Okay? So you do the algebra right, you get something that looks like this, no solution. We're done. Now you might see this right away like this, and you might see it later on. Now, once I got what y is equal to, I could have plugged y into the other equations, but I got a fraction there, and I really don't like dealing with fractions sometimes. So I just went through our regular process. So that's what it looks like when you get no solution. Now, like I said, a system that has at least one solution is called consistent. A system that has no common solution is inconsistent. So what we're going to do is we're going to take a look at this one here and determine whether it is consistent or inconsistent. Okay? So here we go. The question I have for you is, what do we get rid of? The x's, the y's, or the z's? Okay, so we're going to get rid of the y's. So that means I am going to take this middle equation and multiply it by the top and the bottom. So I'm going to have 5x plus y plus 3z is equal to 9. And I am going to take negative x minus 5y plus 3z is equal to 7. And since I was told to get rid of the y's, take this top equation here and multiply it through by a 5. Is that legal? 5 times 5 gives me 25x. 5 times y plus 5y. 5 times 3x, or 3z, gives me 15z. And 5 times 9 is 45. Okay? So, this gives me 24x, y's disappear, plus 18z is equal to 52. So far, so good? Remember, those of you in the studio audience can follow along with this rather than just zoning out. So, now I'm going to take this equation and that equation. Do the same thing over again and wipe out the y's. So that's going to be 5x plus y plus 3z is equal to 9. Then I am going to have 2x plus 10y minus 6z is equal to negative 4. I'm going to multiply the top equation through by a negative 10. That's how I get rid of my y's. So that gives me negative 50x, negative 50x minus 10y minus 30z is equal to negative 90. Oh, 30, yep, sorry. Negative 30z. That's why we got to show our work, so I mess things up. So, this turns out to be negative 48x. Y's are gone. Minus, this disappeared, or this goes to, let's see, this helps if I make sure I do 30, so that would be negative 36z is equal to negative 94. Is that better? Now, is this going to happen that you're going to get big ugly numbers? Yes. This does happen. Sometimes that's why I'll try and pick on smaller numbers. Personally, I probably would have gotten rid of the z's on this one because I got that 3 and that negative 6. But again, it doesn't matter which ones you go for. So I look at this and I say, what should I get rid of now? And I kind of think I'm going to get rid of my x's here because this is a 24x, that's a 48x, negative. It's double, right? So we are going to take this equation here, multiply through by a 2. So 2 times 24 gives me 48x. 2 times 18 gives me 36z, correct? It's plus 36z. 2 times 52 gives me 104. So when I combine these together, negative 48x, positive 48x disappears. Negative 36c, positive 36c disappears. So this side went to a 0, didn't it? And this is going to be equal to 10. Is 0 equal to 10? Ever? No. No can happen. So that means that this is going to be an inconsistent system. But you have to go through the whole process until you run across an error. Okay? Sometimes the error shows up like this. Sometimes it shows up where the y is two completely different numbers. Questions thus far? The process that we're using is just like we had before. Is it easy seeing how to go through and do this? Really, you just need to pick a variable and get rid of it. Calculator will help you through with the large numbers when you multiply. So don't worry about that. So let's try this one. So my question is, which one do you want me to get rid of? The x's, the y's, or the z's? Z's. That's the easy one. Because I've got that, I got those things. So I think what I'm going to do is I am going to get rid of I'm going to pair these two up first. Okay, so that gives me 5x minus 9y minus 6z is equal to 11, and negative 5x plus 9y plus 6z is equal to negative 11. Well, that disappears, that disappears, that disappears, so I get 0 is equal to 0. Well, that was pretty quick and easy, wasn't it? So, which one will this be? Consistent or inconsistent? Huh? Back, 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 back. Infinitely many. Consistent, dependent. So, that means we end up getting for this one, consistent. Why? Because 0 is equal to 0, it's true. That means that they are going to have to be the same. And actually, the first two are the same lines. So, one more. This is investment. Okay, you're going to invest this. Now, some people always ask, why in the world would you want to put something in at 5% and at 10% and 13%? I would rather have it all at 13%. The problem is, the higher the percentage rate for investment, the higher the risk. Okay? Where 5% might be a nice, safe one that you'll know that you'll get your money out of, 13% might be an extremely risky investment. Kind of like if you're investing for the Vikings to actually win the Super Bowl. Okay, yeah, you wouldn't want to. They would definitely be the 13%. So as a person invests $12,000 for 1 year. He invests it in 3 different places, right? So that means we are going to have x plus y plus z is equal to $1,200. Because we're putting them in 3 different places. It's like, how do you set these equations up? That's what I wrote. Yeah, I know. My brain was working. So, 3 different things. All 3 of these things have to add up to $1,200. Now it says, sum is invested at 5, at 10%, and at 13. Combined interest earned at the end of the year from these investments was $920. So that's how much money we've got to make. So that means that we can put it as 0.05x plus 0.1y plus 0.13z has to be equal to 920. So whatever money I put in for x, you get 5%. Then I get 1% or 10% off y and 13% off z. So that's that equation. What about the last one? Now it says the amount invested at 10% is $4,000 less than the amount invested at 5 and 13. So, what does that got to look like? Well, I've got the money for 5 and 13. Well, 5 and 13 turn out to be what? 5 and 13 we used here at X and Z, correct? So, I got X plus Z. Let's see, amount invested, 4,000. What's going to be more? Is the one at 10% for more or less? More. So if I knew what the 10% one was, I'd have to give that another $4,000 to get to the other one, right? So that means we are going to take Y plus $4,000. Now I wrote that off to the side a little bit because I wanted to give myself if I want them to be equal, what's supposed to be? Okay. So I combined the 5 and the 13. So when I write this equation over here, I am going to write it as X minus Y, because I'd have to subtract Y to both sides, correct? To get them all on one side, minus Y plus Z is equal to 4,000. Now that last equation, yes, I understand, is a wee bit on the tricky side. So, which ones should I get rid of? The X's, the Y's, or the Z's? I kind of like the Y's because I got that negative in there. Okay. So, if I take these two first, that means I have X plus Y plus Z is equal to 12,000, and X minus Y plus Z is equal to 4,000. That means that 2X, Y's are disappeared, plus 2Z is equal to 16,000. Does that track? Now I'm going to get rid of these two. So I'm going to take 0.05x plus 0.1y plus 0.13z is equal to 920, and x minus y plus z is equal to 4,000. So, if I want to ditch the y's here, I would need to multiply this one up here by 10. That makes sense to do, because that'll move the decimal point over one place on every one of them. So that gives me 0.5x plus 1y plus 1.3z is equal to 9200. Remember, decimal points just goes over 1, over 1, over 1, over 1. Combine, I end up with 1.5x, that disappears, plus 2.3z is equal to 13200. When you start dealing with real numbers that could happen in real life, things get ugly, things get messy. So now the question comes by, which one should I get rid of? Should I get rid of the x's or should I get rid of the y's? Either way I do this, it's going to be an ugly one, but I think I'm going to get rid of the x's. Reason being, if I take this equation through and multiply it by, let's see. Okay there? multiply it by a 3, I can get to 6x plus, I'm going to actually multiply it by a negative 3, minus 6x minus 6z is equal to, that would be negative 48 with 3 zeros, correct? 3 times 16 is 48. Negative gets you negative 48, the zeros are still there. This side, I'm going to multiply it by 4. With actually 4 15s, that gets me to a 6x, yes? And let's see, 4 times 23, that'll be 46, that'll be 92, right? Minus 92z is going to be equal to, now, I'm sorry, somebody's going to have to take a calculator and take 13200 and multiply it by 4. I'm not going to do that. Sorry. We got a calculator out there? Oh, come on. 52,800. Okay. So, that goes to 0. That goes to negative. Oh, hold a sec. That was a positive. I'm sorry. Got to make sure that I'm getting things in there, right? So that's going to give me 86c is equal to, what's the difference between those two? 4,800. 52,800 minus 48,000. Oh, come on, you were doing so good at the calculator. You had the number right there. Subtract. What'd you get? Oh, these two right here. 52,800 minus 48,000. 4,800? That's kind of what I figured. 4,800. Now, the last thing I got to do is divide by 86. Divide by 86. So z turns out to be equal to what? $55.81. $55.81. Something seems a little on the fishy side. Yep. Can't times. Okay, so I got an ugly number. Is it possible I did something wrong? It's always possible you done something wrong. That's why we write out and show the work. 9 times out of 10 is when you copy something down that you end up messing it up. Doing math in your head doesn't always work either, so I'm going to double. What? Well, we got to check. 2x, that disappears, that gives me 2z, gives me to that. So does that, the red one look good? Did I write everything down correct? What about the green over there? Did I do that right? Anybody see a problem with that? And sometimes this is exactly what you've got to do, is you have to figure out if your answer is correct. By the way, I see some of you got the book open there. What was the answer supposed to be for Z on this particular one? 1,500. Oh, something really went strange here, right? Yeah, I did that. Well, I see exactly where my problem is. Anybody see where it's at? Yep, in the purple. I see it now. What's 4 times 2.3? Is 4 times 2.3 going to be like 92? No. It would end up being what? 9.2. There's a decimal point missing in there. That would change the whole darn thing, right? So, like I said, you gotta watch when you're writing things down. Something didn't seem right there, so that means we end up here with 3.2. So we got that. So 3.2, divide both sides by 3.2. What is 4,800 divided by 3.2? 1,500. Okay? So we got that. Always sit there and look and check. So now that I got z is equal to 1,500, I can plug that back in. And the thing is, I'm going to plug it in up over here, because that makes life a lot easier, doing with twos and decimals, right? So we've got 2x plus 2 times 1,500 is equal to 16,000. So that means that's 3,000, right? Yes. Subtract 3,000 to both sides. Subtract 3,000 to both sides, and we end up with 2x is equal to 13,000. Divide by 2, divide by 2. X is going to have to be equal to what? 6,500. So, we've got z at 6,500. We've got x at, sorry, no, see what I mean about checking your work? Kind of like Santa Claus, you gotta check his work. What? No, I didn't take 1,500 base. Well, no, because it was a 2 in front of that z, so I had to go 2 times 1,000. Yeah, that's where that one's at. So, x is 6,500, z is 1,500. So, if I put those together, that's $8,000, right? And I end up with 4. 1, 2, 3. So, 6,500 at 5%, 4,000 at 10%, and 1,500 at 13% will give me $920 at the end of the year. Yep. Ready about there? So, tomorrow we are going to go through and work on the practice problems. So, here in